Hi, this is Mr. Roix, and today's video is going to deal with matter and how we go about classifying matter. So first of all, a quick and simple definition of matter would be anything that has mass and volume, which is nearly everything, with the exception of perhaps energy, which comes in various forms. So we'll deal with the properties of matter and how we would go about classifying matter. There are two major categories for matter. The first would be pure substances, which are often referred to as substances, and then mixtures. So we'll look at each of those individually. First, dealing with pure substances have distinct properties as well as constant composition. So basically what we're saying is if we took samples of two samples of a particular pure substance, we would find that both samples would be exactly the same and would have the same properties. The two major subcategories under pure substances are elements and compounds. Elements are the simplest form of atoms, and elements are unique, or I should say atoms of a particular element are unique to that type of element. Compounds contain two or more types of atoms that are bound chemically. Substances cannot be broken down further by physical means. They are as simple as forms as they can take physically. Mixtures can be separated into two major categories as well, or subcategories. Those would be homogeneous mixtures and heterogeneous mixtures. And I apologize for the spelling mistake. Homogeneous mixtures are also uniform throughout, but consists of several types of elements that are not bound chemically, or several types of compounds that are also not bound chemically, so they can be separated out by physical means. Heterogeneous mixtures vary throughout. So again, once you've figured out that if they can be separated by physical means, the question now comes to whether or not they're heterogeneous or homogeneous. If you took two samples, do they match up? Would they be the same? In a homogeneous, the two samples would look the same, whereas in a heterogeneous, the two samples would vary. So let's practice with some of these and see how you do. First up is water. So again, the question you want to ask is, can it be broken down any further by physical means? And if it can't, then you know that it is a pure substance. And then once you know it's a pure substance, the question is whether or not it is in its simplest form, meaning is it an element. And so water, as hopefully you know, is a compound. It is a pure substance and it is a compound. Trail mix. So trail mix obviously can be separated by physical means. You could pick out all the M&Ms and leave the nuts and raisins for other people. And so since it can be separated by physical means, it's a mixture. And as a mixture, again, you could take a sample, and one sample could have a lot more M&Ms than another sample, so that would make it a heterogeneous mixture. How about copper? Copper cannot be broken down any further by physical means, which means it's a pure substance. And then the question is it in its simplest form? And copper is an element, so therefore it is in the simplest form as atoms. And therefore it is an element. How about the atmosphere? So can the atmosphere be separated by physical means? Well, actually it can be. not necessarily what we would think as easy physical means, but it can be separated by physical means. And so since it can be separated by physical means, it's a mixture. And now the question is what type of mixture it is. And the atmosphere could be considered a homogeneous mixture, all right, with the same percentage of nitrogen, oxygen. Mixtures can be tough to classify because of the fact that it really is somewhat dependent on the sample size. So I'll try to deal with fairly straightforward examples of heterogeneous versus homogeneous mixtures. Try to keep things straightforward. All right, I guess that's it, and we'll see you in class.